Good afternoon, gentle readers. Today is November 25, 2024. And today, from a deck with Ross Finlayson, is Logos 2000. More physics and philosophy. So, in the past couple episodes, it's been largely about the philosophical account, philosophical currency, philosophical theory, and the reasoning why reason and rationality arrive is from our considerations of the real and the natural, the de re and de natura, this de res and de ratio, these Latin terms which mean the rationality and reason for this reality and nature. So, with that is said, then, a couple of the issues with regard to this idea that it's a sum of potentials, as of a sum of histories, a least action with a minimal gradient, that is the account of the thing, and then its energy is conserved in this field theory or gauge theory, that's as well as of a sort of entelechy, that the connectedness of the entelechy is also conserved. And so what we have as conservation is also, of course, continuity, and that these are the kinds of things that fully become logically entailed, so that we can begin to arrive as from a theory at all, the theory at all, a theory. So one of the ideas I came up with the other day was this. It was that looking at 0 meters per second and infinity seconds per meter is that in a given course of time, that something that is 0 meters per second is only 0 seconds per meter for a given amount of time itself. And so what this gets involved is counting everything, that anything that's 0 seconds per meter is infinity meters per second, and vice versa, has an infinity side. It just becomes a growing thing, vis-a-vis how long something is at rest, indicating a staying thing. And so then with regards to that, what's arrived at is that counting these things again is also its own thing in motion and is so changing. And so is that again, and so is that again. So it just helps to reflect, again, the infinitely many higher orders involved with acceleration and anything such matters of rest and motion, meeting and parting, starting and stopping, and these things which make to entail that the logical theory arrives for these objects of mathematics, then the objects of the physical theory also just arise directly from it. So in this way, it can be said and understood that a mathematical universe hypothesis is perhaps a bit closer than otherwise usually thought to think, because it's not that far at all from just a usual kind of notion. This is where our theory starts with nothing, and then there's everything in it. So nothing and everything are these opposites, and sometimes it's represented as like void and the one, or something like that. And then the idea from the previous talks about geometry logically has that an axiomless geometry arises that points are right next to nothing, and space is almost all of everything. And so that complementary to each other, then it makes for this reasoning of the spiral space-filling curve and the universe vortex, as it were, or the world vortex, and this world's turn bit, that it arrives at the reasons why then that's what defines what makes straight lines as shortest distances, and right angles as those that arrive the most distant apart or in entirely different dimensions. So it's just more of the bit that the axiomless geometry is well-founded and arrives at the same things that we make from Euclidean geometry, and that then the acts of making actions of the constructions of the classical constructions of the compass and the edge are as to so follow. So in foundations, or for a theory, when we need something like a logical theory and that it has geometry, and then for numbers, it arises all quite perfectly from this and that, and that's usually always over the course of history considered, but then arrived at that nothing can arrive from nothing, that there's no creation or destruction, that it's just conservation all the time. That here it's the kind of just this most brief, minimal, mere account of a teleology, the silver thread, the Shastra, connecting them together so as to arrive at that instead of this, how one might say, unfounded assumption from nothing, just from the stipulations themselves, that instead what's found from nothing is a founded assumption. And it is foundation in the sense, the ground, the alea, the grund. So let's see what the books have today, and I'll try to gather from them some of these ideas that will help to further fill out the connection between philosophy and rationally and reasonably logic and the mathematics, all such matters of structural form and relation. Then the physics and the statistics and probability is after that for science, because it's all one theory, and these things arise as altogether from quite one thing. One way to look at the theory today is often considered the analytical discourse of the logicist positivism. That's the half truth, or a single perspective, fixed perspective from what we have of this wider theory. So when it's like that, then this logicist positivism account can make for very, very brief and small theories. Whether it's just a theory of a finite state machine, or a theory of traffic lights, and those as with regards to otherwise closed systems of the very, very small in category and type, that it makes for a very, very brief account to arrive to be able to pick up and put down those sorts of things with the least amount of ontological commitment, whereas as well the most surety arrived at. So then it's this wider idea is that, well, everything's kind of got to arise, and then those such things as well are as simply as so, and they can still, according to science, and so this being a scientism, this logicist positivism, picked up and put down, it has that there's no need to give either of those, either the ideals or the analysis, and this ideal analysis and this analytical idealism. And it helps a lot when it gets around to the inductive impasses of reason that in the infinitary would fail. That has a deductive account that helps to arrive at why things are kept true. So for things like Zeno's theorems that the limit exists, it's not that the limit might exist and we don't know, it's that the limit exists and our infinite cases can have something to attain to. Like from reading Schopenhauer the other day, and it was like, well, Schopenhauer, I see you made a great analytical account and you don't need anything anymore. It's like, well, the rest is just hidden. And he says, we must know what we're talking about before we talk about something. That in this same sort of course, to agree to arrive at this wider milieu, then it must so exist, and that's the way it is. So these are comforting, fulfilling sorts of notions that make for then this wider ontological commitment that then from such brief principles as described in the past few minutes, it's possible to arrive at all the objects of geometry, and from those to make arithmetizations and algebraizations of pretty much anything according to a language of words, according to the symbols and symbology. That this not being very much the usual modern account of things, which is all analytical logicist positivism, this still it arrives that this is the thing. This is a theory that can be true and consistent and complete altogether again. And that it includes this notions, a place for the super scientific, the super sensual, the supernatural, as with regards to the omni, the omnipotent, the omniscient, and the omnipresent, which are external it, yet as of about it. So that's just the usual kind of introduction, I suppose, for these usual kinds of things. This Logos 2000 here today. Let's see what the books have. This first one is from P.T. Raju. Pula Raju has written The Structural Depths of Indian Thought, and is warmly appreciated because what it gives is a very great account of the details of the development over the 2,000-year course, pretty much, of and since before that, but especially since the times of the about 1000 A.D., the details of the structures of the technical components of the Indic and Hindu traditions has come up after the Vedic and the Jain traditions, which made the Hindu traditions. And then as with regards to the Dravidians, then also the peoples of Mohenjo-Daro of that time and place, that after about 0 AD and the advent of Buddhism and Christianity, that these as reasoning and philosophical traditions quite thoroughly have arrived at then the scholasticism as we see in the Christian dogma, or the doctors of the church, or often Aquinas and Duns Scotus and Occam, and Duns Scotus is my favorite of these people most usually. Then the ideas of the Indians, that they also have relevant parallel figures, or that those other figures are relevant and parallel to them. that there's a unification considered as with regards to some of these great steps with regards to the transcendental ego. Now, one thing Raju mentions, or a personage in a school of a man, that is relevant because this book he wrote it is said to be considered as the history, and it includes the Western tradition very much so, is Spinoza. So Spinoza was a transplant Dane, and he lived in the time of after Descartes, and then it's said that he was very familiar also with the scholastic traditions, and so that would be for Duns Scotus, and that infinity is in. And one thing to say about it is well, he just kind of is very much like Arnauld, and yet very, very deistic, that he frames things in terms of the universals and uses a language relevant to that, which in the time of the day would have been deistic. And at the same time, what he does is he introduced that there's a sharp distinction between the finite and man and infinite and the deity. Yet at the same time, he brings in, there's this whole infinite range of substances. So Spinoza is also known for having the infinity as in the theory. And the infinity is something that we comprehend, and the infinity is something that's available to our senses, or at least our mental and object senses and faculties. So Spinoza is a very relevant thinker with regards to that, because after Duns Scotus basically opened up the very door to make for this supernatural vis-a-vis the supernatural, that this extraordinary is this extraordinary, that this is one thing to consider with regards to the variety of these traditions. Then in many other courses, it's put forth the ideas of the infinite, and it's always pretty much translated that way of the substance or the essence and these kinds of things, the supreme, usually the absolute. But then here, kind of just as with regards to the mentally tractable, as with regards to geometry and the methods of exhaustion, the means of exhaustion that arrive at analytical results in geometry, or as like considerations that a circle is like an infinitely sided regular polygon, and that it can be measured its area by splitting it up as if by infinitely many triangles centered with their, rather with one point of the origin and 2 points on the chord with the width that goes to 0. Both ways. It goes to show that infinity is both a concept that's carefully excluded from the analytic because it's intractable to inductive inductive inference, yet at the same time very, very strongly supported as being part of the theory, because otherwise it wouldn't be available to deductive reasoning at all. Then after it is, then we can point back later in this tradition of the Zeno and all the Zeno's arguments to make that those are cases of the usual classical expositions of motion and infinite divisibility and the limit of the geometric series. That as well, those are the same grounds for reasoning about the deductive aspects of the completions, that after not merely partials, they are the completions of these things. That this is a nice usual thing that's kind of made of it. So in Kant's philosophy, we find further removal of the mystery of the relation between our mind and God's mind by Kant's introduction of the idea of the transcendental ego. But still the problem is not fully clarified, as Kant did not say in definite terms that our transcendental ego is the gateway, as Raju puts it. Hegel seized upon the clue, turned Spinoza's substance into self-consciousness, and changed God in Kant's God include the transcendental ego and the transcendental object to the absolute mind or absolute consciousness. So this is just a reading that is with regards to something like Descartes, and as kind of put up yesterday, that Descartes and Schopenhauer are very much repeating the same thing of each other, except one in terms of this deism and then also affecting whether it can actually affect affairs, and then that for Schopenhauer it was a mere qualitas occultus, or a hidden quality of things, as with regards to the discussions of the hidden variables and these kinds of things from these earlier talks. That it's very synthetic, that when it comes together, that these kinds of approaches to making for the reasoning and the rationality, as with regards to the omni, as part of the super, that it's still, we can consider that from just a usual 0, 1, and infinity of numbers themselves. That is quite a nice thing. And then he talks about matters of perspective and projection, and a lot of the Vedas with regards to Atman and Brahman are also like that, because it'll show and declare matters of perspective from one perspective and matters of perspective in another, exchanging the names of the interlocutors and players and agents and actors, these people of the thing, while at the same time leaving that their perspectives are their same perspectives as they would have for themselves. And so that over the course of them, from each of these different, they're like 7 or 8 good Vedas that have each one its own kind of case, that after something like Zeno's arguments of motion, then the 7 or 8 Vedas of the Indian really make for perspective and projection, that would be a pretty usual way to establish a technical means for these things. So this is talking about the Carvaka. So I kind of equate the Carvaka with the Epicureans after the Platonists and the Pythagoreans. The Carvaka and its anti-Vedic materialism being the name of this chapter. So you might say the Carvakas are like the Stoics or what, in that sense, those who have that there's introduced psychology after philosophy, because philosophy need not necessarily include psychology at all, though it most directly does. Because philosophy can be for things that would exist even for unfeeling beings, or those in terms of the psychology that admit nothing yet but either perfectly advised form and structure or perfectly blind and mute form and structure. So when it talks of the psychology, the philosophy is to be considered that also becomes an ideology of sorts that is not so necessarily germane to what's otherwise the technical philosophy. So then when there's matters of trying to relay that in the wider analytic tradition of the technical and logical, that phenomenology is always a thing, that phenomenology is always just a matter of our senses and the way things could be, that is well to be considered and arrived at, that those things may also as well exist on their own interobjectively. So the whole realist position in physics is kind of a rejection of logicist positivism. But at the same time, the very strength of logicist positivism is that it does give reasons for reason why to have the own theoretical account of things. So that both mathematical Platonism and logicist positivism are relevant and necessary to have a thorough reasoning, one otherwise just kind of submission and submersion in belief, and the otherwise just kind of the absolute rejection of anything but just things that might be true, that somehow they're connected together to make for then this wider theory that exists, at least, so we have something to attain to. And then when things are arrived at, like geometry and numbers and other perfect objects and mathematical theory, that they always exist. So he talks about the Prabhakara and the Mimamsa, and these are terms I have yet to learn, though I became somewhat acquainted with them in this previous reading of some of the sections of this great, thorough work. The reader can see here that Prabhakara means the meaning of nouns dependent on the meaning of verbs, and is nearer the Nirikta theory that the noun is only a modality of action than Kumarila, who treats the meaning of nouns as independent of the meaning of verbs. However, Prabhakara's view should not be equated to the Nairukta view, for which action is the primary reality and is the Atman itself. There is another difference for both Prabhakara and Kumarila. Action, karma, is the sovereign of the universe, but it is different from the material constituency of the world it governs. But for the Nairukta, action as the Atman includes everything as its mode and forms, we may say, the philosophy of an advaita of the Atman as action. However, Prabhakara is closer to the Nairuktas than Kumarika is. We may note also that Sriharsa condemns Prabhakara as a kinsman of Buddha, as he tends to hold like the Buddhist that the primary aspect of the world is activity, process. This controversy makes us think that the Buddhist doctrine of the momentariness of the world as a process is very likely older than Buddha himself. We find it in the earliest speculations of the philosophies of language. So that just goes to help reflect that the Atman and Brahman then, besides just being things like, the mystic soul and the act of becoming and all this kind of ideas kind of from the account of that's matters of personal development and the transcendental meditation and the transcendental development, this as well as these matters of thinking things over and the knockabout and turning things over and how they are and why they are. Action can rightly be interpreted, as the Bhagavad Gita does, in interpreting sacrifice as a sacrificial oblation, homa, of the whole plurality. the horse sacrifice, the world and man's psychophysical plurality into the unity of the self, Atman. It may be said that the Vedantas, particularly the Advaitas, opposition to the way of action, karma marga, is due to the degeneration of the Mimamsa theory of karma as sacrificial activity is purely ritualistic. He said that Jamini, the author of the Mimamsa aphorisms, was originally the author of Vedanta aphorisms also before Parayana. If he was, he must have reconciled action and self-realization there, but we do not have his work except in some references. We have only his Mimamsa aphorisms. And so this goes to show that, much like these other ones, that there's a lot of these things that kind of bring together what are these, what survives, the fragments, that also are tabulated as like, these are truths, this is wisdom, and in such brief form that then it must be read generously in all its ways. So I'd look to study that for more, some more rather. And then what I was curious to find was something as with regards to Panini, who was this grammarian in the early part of this story. And he's mentioned on pages 17 and 19 here of this book, according to the index. And so on page 17, about the epics, they do not seem to have distinct philosophies of their own, where a philosophy is like an entire world theory. So the idea of having a theory is that anybody can have one and have their own philosophy, vis-a-vis there being a strong one that also equates to knowledge and science and wisdom and intelligence. So these otherwise are, he's just saying that that's not something that we might so had. Said, for proper understanding the Vedas, a number of subsidiary studies were necessary. Phonetics, ceremonial, grammar, etymology, prosody, and astronomy and astrology. There are 4 secondary subsidiaries: epics, logic, rules of textual criticism, this is the Mimamsa, and ethical codes, the Dharma Sutras, Dharma Sastras. But curiously enough, some of these subsidiaries themselves develop their own philosophical systems. So that can get into reasons why is of psychology and these kinds of things, or with ethics and morals and associated things, while logic and grammar might be seem very close, and then it doesn't really have anything here as with regards to mathematics proper. Here's with regards to Panini. Grammar was started by Panini, who lived sometime between 6 and 300 BC, and expressed a number of views on the philosophy of grammar. His views and those of a number of his commentators were developed in a system of philosophy by Bhartrhari, 6th century AD. It is a philosophy of being developed in terms of the significance of the grammatical subject and predicate and of the meaningful word. Yaska, 8th century BC, the author of Nirukta, first lexicon of the Aryans, developed a distinct philosophy of language, treating the meaning of the grammatical predicate, the verb, as a primary reality, thereby equating being to activity. He gives several names of earlier philosophers of language, but we do not know anything about their works. Prosody and astronomy do not seem to have definite philosophies, except for the view that they have effects on human life. As the epics now stand, every one of them expounds in an easy, popular way many types of philosophy. So yeah, I wanted to look at that for a little while. This Raju is by studying it some more, I become familiar with the main philosophical persons, the schools of the people, with regards to knowledge and otherwise, as he puts in the title of his work, the structural depths of Indian thought. It's a book by Einstein and Infeld. So Einstein is pretty famous by this point, and then Infeld was brought in as like an author to help assist him. This is copyright 1938, and he gets into they gets into the theory of the fields, and also things that by this time, after the great success of the particle theory of the fields, then as well the wave theory had become so much, how one might say, shown and demonstrated that it's both particle and wave, as with regards to these various actions of it. Mostly with regards to electron physics and the discrete electron transitions, and those being like states that also could be seen as like resonant waves of particular resonance frequencies that only form their harmonics that stand in this way. So it always goes without saying that another way to look at discrete orbitals or discrete energy levels is to look at them as happening as a maxima of otherwise these constructive interference, which is called the resonance theory. So the wave-particle duality is, again, the wave-resonance dichotomy. And that goes without saying when it's a continuum mechanics. And then when there are theories of hidden variables, it would usually be considered they would be expected to include being waves again. Not that there's hidden variables like, well, I kept looking at the toaster and finally the toast came up, so I must have had something to do with it. And this kind of confirmation bias of the anthropocentric view of things, vis-a-vis there's really continuum mechanics, and actually when we stuck the probe in the quantum system that it arrived at actually shortening it out and causing its own effect. Just as like when there's the dual slit experiment and interferometry demonstrated that it's not just so much like, well, we changed the experiment, is like, well, that is his experiment. So there's something to be said for that. This book is like after the great success of electron physics and also establishment of the waves. So it's also very, very kind of easy talk about what it is to be these things and be these waves. In order to better understand the mechanism of the wave, let us again consider an idealized experiment. Suppose that a large space is filled quite uniformly with water or air or some other medium. Somewhere in the center there is a sphere. The beginning of the experiment is no motion at all. Suddenly this sphere begins to breathe, rhythmically expanding and contracting in volume, although retaining its spherical shape. We call this pulsation usually, with regards to theories of stellar pulsation, and as with regards to things like the wave as a wave as a wave, this area in the region of it, that just represents its amplitudes, and they're cyclical and periodic as well. Then what that means for things like, at motion and at rest, and these ideas that this sphere has everything about it conserved and nothing ever created or destroyed, although anything that's a matter of transition can be seen as both while conserving something else. That this is kind of thing that one thing to consider is about the ether theory, because the ether theory is the idea that there exists a space itself, and so everything is kind of about and in it. And so some people said that it was long ago discredited or disproved, but actually it's kind of so, like Einstein says in his sidelights on relativity, is like talking about the ether theory, and the summary is at the end is that there is an ether. And here, for example, for a space and this kinds of things in the differential system, but then as well, this one of the ideas of kind of talking back or walking back the idea that there isn't these things, is the book of Einstein and Infeld goes a long way to what is necessary to kind of walk back these things that were kind of taken by people who didn't kind of have a dualistic view of these things, which are dualistic themselves, that otherwise it wouldn't be so that later we just point to them as being wrong. So that it goes to say then that here these kinds of examples that they're giving are meant to be kind of inclusive and holistic and expanding. Well, at the same time, according to all our principles and according to all the observations, so that it's a valid and sound theory with regards to the land of not crazy talk. Similarly, when the sphere contracts, the density of that part of the medium immediately surrounding it be increased. These changes of density are propagated throughout the entire medium. The particles constructing the medium perform only small vibrations, but the whole notion is that of a progressive wave. So that just goes to show that the whole model of wave as models of change in open system is pretty much just as simple as it can be with regards to that it's once only a linear thing, and as well only a radial thing, as well only a essentially symmetrical thing, that the wave is always considered to have these properties according to points and whatever space it's in. So a wave is also has a very ready geometrical interpretation. It's kind of riding along and also in the middle, and as regards to why waves are so usually part of theory, and the theory is so often as of waves. Talks about wave numbers and various the qualitative aspects of wave theory and the descriptive aspects of wave theory. The particles of the medium Yeah, what I wanted to mention about that is that Einstein, in his article in Sidelights and Relativity, said, yes, there is an ether. So it's with regards to electromagnetic theory and things arrive as like, no, there is not an ether. It's like, well, there is again. So that's just yet another thing that the entire theory of physics has to accommodate. And then this is a section we read before briefly, and so it's kind of with regards to as he puts it, the corpuscular language and the wave language, and then here also to include this resonance language above waves, yet as of waves, but that regards to anything that could be considered a point or a wave or a resonance could also be any of those three in the wider continuous milieu, because it's only in the discrete milieu where they have these intersection points or crossing points at all. Only in the center, only according to the origins of these spaces and these subspaces. And this continuous manifold is this reticulum of all this space and time, and the uppercase space and time, the contents within it, that it goes to show that the language here details these different structures and these inner and outer products as vis-a-vis the direct and natural products are all these things that they could be. And so when talking about the hidden variables of quantum mechanics and that kind of theory, then it arrives at, it's like, well, it's got to be about how these things make it so that it's an entirely included theory, and then all we have is these quantum mechanics in our theory of histories and theory of potentials is just again reified as of these, the waves, particles, and resonances. So that can go a long ways to help when people are kind of stuck with particle theory and just keep looking for more particles, and it's kind of like that was already the inner product, and then it's with regards to its supersymmetry and bending and breaking it, supersymmetry with at least three kinds: macro, micro, and meso. The supersymmetry in the macro, it just comes up as like, and you know, this wave's totally negligible effects have been overcome by this otherwise the nonlinear, or this doublet of the Higgs boson. That as well, right in the middle, it has the same thing to be figured out, not by making smaller particles, but rather by making reflections of that the particle is a wave is a particle, and also as a resonance, that a particle is a wave, and besides that, particles make waves. So waves are self-similar and fractal and fractional and extraordinary this way, and it's part of superclassicism in theory. So beyond particle-wave duality is that particles and waves and resonances are also each other again. So that's a usual nice way to say that it's a continuum mechanics, this quantum mechanics. Talks about diffraction. One of the greatest things about diffraction and light, and like when you block light, and that like if something in the shadow, and that if for a round object in the very center, it has a spot of light, and it's called the Arago spot, Arago, the Arago or Arago spot. That it's a totally simply demonstrable feature of light that is super classical as well, and show that light takes corners, light orbits and goes around things. There's considerations of the sky survey, why redshift is everywhere, so the expanding universe. And so the usual idea is that that's Doppler. What Doppler effect means, like the sound of a siren or something of constant frequency itself, arriving and receding, that the frequency increases and decreases, that light is the same way. And so something that's decreasing falls off as redshift, and something that's approaching shows off as a blue shift. So when they look at the sky survey and found that this redshift everywhere, then for a while that was just interpreted as like there's redshift everywhere. But now when other experiments with just looking at light or electromagnetic media kind of also found that it was much more that was redshift bias, that actually it's not 99% of the objects in the sky are receding and falling away from us, that 51% are. And so it really changes entirely the grounds for how things are interpreted and put up and figured out for all this all the rest of the data and all the rest of this theory. So the idea for the redshift bias, to explain it and how it may be arrived at, and kind of classically, is that this whole rotating frame bit of the kinetic frames and rotating frames being independent also make for that as light arrives, light's always orbiting and not traveling the geodesy so much. So it kind of like also lets light out of being part of the geodesy, but it also follows kind of according to around things, vis-a-vis their mass and vis-a-vis the medium and being an occlusive medium for light. And so, and yeah, the mathematics have to line up the same for the usual kinds of theories. They do. And then the idea is that the rotating frame of the galaxy both explains why the gravity shows up as the galaxy is kind of an independent medium and not spinning itself apart. It's just kind of spinning as a disk, and everything else spins around it in terms of it being independent, free rotating frame. That then for the light coming in, all the redshift bias is accumulated because that's kind of the Doppler all the way around, see? And so this is another way to look at physics. So that when you arrive at why the sky survey, it's seemed biased, is because it has one to remove, because the theory didn't entertain that this large lensing or this down-Doppler is in effect. That by adding that into effect, all of a sudden everything that looked like dark matter blowing up and dominating the universe, or dark energy blowing up and dominating the universe, is gone. So that is a pretty serious thing with regards to why then a theory of gravity can also be so simple. How simple can it be? Well, it's got to be entirely infinitary, and as if from the outside of the universe and flowing inwards, infinitesimals at infinity speed all the time. Then things just kind of naturally orbit and fall together. But then it becomes quite a simple theory of the thing. Huygens believed that the ether would turn out to be air-like rather than jelly-like, whether it's a medium of basically zero or basically one viscosity as with regards to things passing through it. But nature cares very little for our limitations. All the optical phenomena we have considered speak for the wave theory. The bending of light around small obstacles and the explanation of refraction are the strongest arguments in its favor. Guided by the mechanical point of view, we realize that there's still one question to be answered: the determination of the mechanical properties of the ether. So here it's Leopold and Einstein again talking about the ether theory and why it's got to come back into the theory, because it was strongly contradistinct according to theories like Faraday, the great electrician and theorist and experimenter of like 1840s, and then Larmor and Fitzgerald and Heaviside and Maxwell. That Maxwell in the end was like kind of a fresh student amidst all this stuff that had been developing for 40 and 50 years. And Maxwell's like, well, I got a simple theory, and E cross B, and look, the electrical and magnetic fields are cross. And everybody's like, that's it. And it's so easy to plug into Lorentz, that's it. So then trying to figure out how this ether works with Lorentz again, we got Fitzgerald basically having made it so that and then this linear and rotational being different is really the key thing that is different. Because the linear and rotational being different shows up like in the Sagnac effect and whenever the Coriolis effect and these kinds of effects, any one of which is outside the theory. Then we have to make it so that the ideas that otherwise it's linear and rotational get their own settings, space contraction linear and space contraction rotational, have that otherwise the theory is falling farther and farther apart, while such simple accommodations reduce it to a unified coherent whole again, which is some find is very comforting. We shall consider in detail and only one of many experiments which are able to supply us with an answer. Tourmaline crystal, again a point of light, if the plates are sufficiently thin. We shall take as an axis the line of the incoming ray. So we're talking about a ray in a wave medium, and then one of the ideas that comes into play when the idea is to set up something that's entirely linear and equal and opposite is that, as we kind of discussed and arrived at in World's Turn in Moment and Motion, is enough. That's an unattainable ideal except in arbitrarily contrived situations. It's like the light speed being a constant in deep space, in a vacuum. Those cannot be left out because otherwise light speed is, in terms of the space and in the medium, is not so. So any of these setups that are arbitrary, that are all physical and not merely mathematical with regards to the equal and opposite, are contrived because there's always a non-zero, unlinear component. Ether in the mechanical view. ether as a jelly-like mechanical substance. Yet we know from mechanics that interstellar space does not resist the motion of material bodies. And so that gets into the ether as, and like the moving frame overall, that like we're in the Earth's frame, and the frame is in the sun's frame, and the sun is in its neighborhood's frame, and it's usually considered to be like the North Star. So it kind of moves according to the frame because it's kind of free yet in the frame, whereas people on the Earth are usually pretty much always terrestrial, you know, in a kind of a sense. But it does go around, and it's known that the magnetic pole moves and this kind of thing. So, you know, worlds turn. That then these ideas with regards to the equivalence principle and some of the things that are trying to be addressed here are again just kind of fall off, because there's always an inside and an outside, and it's always a turning, and as vis-a-vis that it's at rest ideally is not so. Yet that it is so in this frame, so in the frame. This was Aristotle's circular movement is eternal while there is no unmoved mover. The circular movement is eternal. In the old theories of electric fields, we'd usually say Maxwell's, but maybe it's about Faraday's. In the corpuscular and wave theories of light, we witness the further attempts to apply the mechanical view, but in the realm of electrical and optical phenomena, we meet grave difficulties in this application. A moving charge acts upon a magnetic needle, but the force, instead of depending only upon distance, depends also upon the velocity of the charge. The force neither repels nor attracts, but acts perpendicular to the line connecting the needle and the charge. In optics, we have to decide in favor of the wave theory against the corpuscular theory of light. Waves spreading in a medium consisting of particles with mechanical forces acting between them are certainly a mechanical concept. And then we also call it the photon wave packet. So it's still kind of like, well, in your theory of photons, our wave also lives there, and it's a particle, but it behaves like a wave in the wider thing. There's no hope of reducing the optical phenomena to the mechanical ones before this question is answered. The difficulties in solving this problem are so great that we have to give it up thus give up the mechanical view as well. Or not. Just have to kind of augment it to equip it with a sufficient mathematical model so that the physical model isn't merely partial, yet also at odds and crooked. So that's something to figure out. Let's see here. Space model, field representation, purely mechanical character. Let's take a look at this. This is Cassirer. What it is substance and function in Einstein's theory of relativity. So Einstein's theory of relativity is that this abstraction, the philosopher, so he's talking a lot about the theory. And so when Einstein, out of my later years on his philosopher and his physicist, must thoroughly have been influenced by schools and concept and thoughts such as these from Cassirer, or he read it. And so we talk about objects of the first and second orders. It's significant in this tensity that Erdmann, after completing his psychological theory, the concept, finds himself forced by his consideration of the mathematical manifold to the introduction of a new point of view and a new terminology. So he's talking about a first construction of concepts, uniformity, original, but not the sole condition, progress of thought, and developed presentation. For objects of sense perception, we can designate as objects of the first order. There now appear objects of the second order, whose logical character is determined solely by the form of connection from which they proceed. So that's a mathematical model, usually. And the idea here that our mathematical model has mathematical models, and it's a continuous manifold, and it's also a self-similar fractal, as with regards to these kinds of considerations, then make for these inner and outer products that is neat and simple and natural light is so. In general, wherever we unify the objects of our thought into a single object, we create a new object of the second order, whose total content expressed in relation. And then here he expresses kind of also the inverse type of thing, where it's like we've made a refinement and a further refinement. And so this is the point of reaching towards the utter abstraction and the severe abstraction of the mechanical reduction, but otherwise just like a mathematical model with the least number of components at all. That one sense it's this second order is refinement, and the other sense, as it was in his here earlier, that refinement is like it's got to be like that for the entire universal theory. So it's the same kind of idea of a severe abstraction for all the theory, not just for any given old logical positivist object at all, like the teacup on the train, and all that surrounds it, and all these things. For sensuous experience is concerned exclusively with a particular object or with the plurality of such objects, in summation, no summation of individual cases can never ever produce the specific unity which is meant in the concepts. That's fair. The idea is that metaphor eventually fails, yet the strong metonymy is what it attains to when it does not. And that metaphor need not fail at all. It's perfectly apropos in mathematics, and mathematical metaphor is missing nothing, which is nice. Acts. Its meaning develops out of the various logical acts, in quotes, which can be attached to the content. These acts, which differentiate the sensuously unitary content by printing upon it different objectively directed intentions, are psychologically completely underived. There are particular forms of consciousness such as cannot be reduced to the consciousness of sensation or perception. If we are still to speak of abstraction as that to which the concept owes its being, nevertheless its meaning is now totally different from that of the customary sensationalist doctrine. For abstraction is no longer uniform and undifferentiated attention to a given content, but the intelligent accomplishment of the most diversified and mutually independent acts of thought, each of which involves a particular sort of meaning emphasized of the content, a special direction of objective reference. So here it kind of goes to show that Cassirer is just kind of framing things in terms of these attachments and separation from each little point, falsified, 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 and falsified again, or not, respectively, for each. And each one of those connected to the operational, as this is called, or instrumentalist, as it's called, or the phenomenological, the phenomenalist, as it is, with regards to that. Otherwise, we have our noumenological and object senses above that for our mental reasoning. That he's making a great case for why these things have still their own essential concepts, and so it can be relayed, and then that the how it's arrived at, what makes this sensation, is not so relevant as that it just fulfills that model and role. So that gets to one thing that I thought I wanted to talk about for a little while today, and that's type and category. So type and category are very, very relevant and particularly apropos theories of things that have relations by their extensionality and intentionality beyond just a theory of one relation with like set theory or part theory, like alter or has parts, or ordering and relates, and these kinds of things. So in a type theory, there's various types of relations. There's various relations that are transitive as well, and yet reflect also in the opposite, that it's maintained both ways, the relations, in a sense. And in computer land, for structured programming, the idea to give something besides its place in a geometrization, a geometrical object, or in an arithmetization, a number, or an algebrization, a member of an algebra, and there are many kinds, algebras, magmas, quite widely, that there's also the idea of that it has a type. And so then when in the structured programming, this type is for variously unions or structs, or to begin, just compositions, tuples of what make via ordered tuples of these structured objects in the computer programming, in the usual theory with the structured programming, that then the most usual kinds of ideas with regards to a composition of types is that something has something else, that a number is a value, and that a given particular structure value, for example, called a struct or a class sometimes, but a struct to begin, because structs only have composition of membership vis-a-vis composition of inheritance, that something is a versus something has a. So the idea in type theory that something has a and that something is a then gets into composition of the objects and assignment and reference to the objects that by their given types, then they automatically fulfill the rest of being a model, like in model theory. Like it would have all the fields because it's a subclass of a class with all the fields. because every subclass of a class with fields only adds and composes together, makes a union of all their fields. That a field is a usual idea that a given member is a named field of an object of the structured programming called a struct or a class. So the idea of type and category theory sits above set and part theory, and it's not the same as mathematics, the geometry and number theory, and so it's logical, yet at the same time it's relational, and it very much is so. Then that it's algebraic in a lot of senses, or it's just regards to establishing operators, and the operators are so. It's usually called, with regards to the lambda calculus, it's operator calculus. That calculus allows one to derive it from the various pieces of things, how they can be assembled and put together, and arrive at other given things of known sorts, validatable, verifiable sorts of things. That the type theory thus is very strong. Then category theory is very much related to type theory. And when you think of category theory, we talk about functions between things. Like something will take something of a given category, something of a given category. So this is the translations of types. Like when you have types among themselves, then they all are of the same kind. They all have similar properties. And then the functor in category theory says it takes it from one category to another. So the whole reason to have category theory besides just type theory is how to explain this entelechy, the connectedness of things, vis-a-vis the energy and its quantities, and also as vis-a-vis its qualities. Like you can see energy in the form of heat or light or other forms of energy in the kinetic and this kinds of thing as being of energy and having a measurable amount in this these units of the dimensions, and as well to reflect in a subtype or a supertype of the inheritance of this constant, this content, this substance, so present in the region of space by the energy as types, and the entelechy is like categories, connecting type theory. So it's kind of irrelevant then that category theory shows up so much in phase and transition diagrams, because then it makes for that as functions with domains of a given type and ranges of a different given type, or images and co-images as the working language may be for functions. Here it's usually domain and range, meaning every element of the domain is in the function and defined by the function, and every element of the range is defined by the function. That the other ideas of support space and so on and this and that are not so relevant. Even in the wider probabilistic setting, that it doesn't make sense to say that something has a support space when really it's just the space itself. When the theory has that the functions are always so well defined. And as is known here from these various long talks, the idea of function theory has that functions are one of the more flexibly defined objects here with regards to functions and topology. And then category theory also very involved in topology when connecting things about with the varieties. So yeah, that's just something I want to mention, was the introduction of type and category theory, because there hasn't been talked about it very much here, type and category theory here at all. Yet it's very apropos, and it's totally usual in all such matters, especially the type theory of well-defined behavior and the simplest kinds of algebras for values. To say then that something is a value of a given type, it might as well just say you're giving it a value at all. And that it's something that's so discernible only by its type, then has that all the relations and rules that hold for objects of everything in the domain and range according to their types, that types and values then can also be reflected upon as with regards to the this inner and outer, the same thing as the particle wave resonance, duality, dichotomy, that each is as of the other from their own perspectives and projections. In this geometry, these algebras about the arithmetics, that inverting the tree or inverting the diamond in type theory is a concept that eventually arrives, because the usual idea is like it's totally inductive and according to inference simple. It's is or has a, and it composes. So all that does is it takes the union of the fields. And that's great, and it is what it is, and it's very fungible, and because it's very easy to pick up and put down. But then the idea that among this theories of types and categories, that then we get up to treating those as of objects of values and making theorems about the types and about the categories, that it can be very, very powerful formalist means that as well has a bunch of different ways to look at it besides those ones that are piled up to say like this goes a million miles an hour in a very straight line, is like this one gets the corners and edges for free and is still a billion times faster than I can compute with a stick on the beach or pebbles in the sand, which still would suffice. All right, then. Let's see. So today has been about some type theory and category theory. We talked about perspective and projection from the perspectives of the ancient traditions and the technical traditions. How relevant it is to have Zeno's expositions, like to have the Bible starting like there was nothing, the geometry of the space, and there was nothing, the word, and then to have Zeno starting the ancient Greeks with the classical exposition of the divisibility of time and the infinite divisibility of things. And then you got the Greeks again with Aristotle and logic after Plato. So you got all these things after Heraclitus and Parmenides to make for Plato to have holistic monism, and even if it's a dualism, it's a monism, and also that it all exists, that it's extraordinary. And then for Aristotle is that also we have an analytical tradition that only can pick one out of the way. It's very Pythagorean about it. And then also that we have Eudoxus and on the Archimedean side and Democritus on the atomic side, both Aristotelians. Then there's quite a ways forward to get up past, and including the Muslim Enlightenment, where there's algebras and arithmetic as an analytic course, and then the scholastics of the medieval philosophers are held up as making for a superclassical consideration again. And as well as after informed by theology, very well informed by theology, which is the omni, its primary consideration, of course, vis-a-vis religion and the relation to man, which is and man's relation to man, which is a different thing. That then there's Cavalieri up after the Miltonian school, and then Galileo. So there's analysis and also the severe abstraction and the mechanical reduction of the theory coming down. So that what I kind of skipped over then is back east, back in the Indic tradition, for thousands and thousands of years, they'd also had the Vedas and these ideas of the perspective and projection. So that goes together pretty much like that's kind of like right between the Bible's account or the Old and New Testaments, nothing space and nothing word, and then this matters of projection and perspective and geometry, and also for grammar, because it also comes up with the grammar of these things. Then into the Greeks, with that being the first kind of super classical analysis, the infinite divisibility and these concepts, that all these things that go on with saying that the point and space dichotomy and the ideas of 0, 1, and infinity come up after that. And that's just why I want to say that there's a way then to kind of help relate these things which become necessary in the technical philosophy, at least to the most well-known and still around traditions that they are. Then today we have things like type theory after logical positivism, and the Lambda calculus and logical relational algebras, relational theory, for all such manners of compositionality and extension and intention for structured programming and all these kinds of things that are very simple and just definitely give means to all these different inductive methods, inductive accounts, and these courses and stuff like that. What it arrives at is that there's a very thorough way to then make it so that then these superclassical accounts don't get lost in the middle. And so when we arrive back up at Einstein and Cassirer, and has seen the great success one way, and now great success the other way, or general relativity and quantum mechanics, apart from each other, 120 orders of magnitude, with no gravity in the middle, which is where it should be, then these ideas of the particles and waves and the resonances coming back around again really make a lot to say that that's kind of where it is today. It's the superclassical and the superclassical and the superclassical again, and now because all the results that have to get relayed to build even one course of this inference to arrive at the formalism and the standard kind of formalism of these things, have to be arrived at these various, very arduous ways. And so then trying to figure that out with regards to how to revisit all these things along the way just takes a deconstructive account of the course, of how it's been arrived at, and doing it over, and finding the way that if it was broken, that it was still complete, and finding out for the inductive account that something may complete, that it does complete. So this is just usual kind of ideas. Well, I hope you've enjoyed Logos 2000 today. I'll think of a title of it. Well, have a great day. Happy Thanksgiving.